Assalamu alaikum. My name is Muhammad Wajid Zulfikar and my registration ID is 16T37. In today's lecture, we are going to discuss about the basic properties on the signal that are the scaling properties, and then we will discuss about the inverse properties, and then we will looking towards the compression, and then we will looking towards the shifting property. Now, first of all, we will start here the scaling property of our system. Scaling. For example, we have a system x of n of 2 of n, and we have the values of the system as this is our system. This is our unit step system. What we do in the scaling property. In scaling property, if we have any value, for example, we say this is 1, this is 2, this is 3, this is 4. In the scaling property, we only divide the values by the scaling factor. For example, we do it as 1 by n, 1 by 2, 2 by 2, 3 by 2, and 4 by 2, and 0 by 2. After doing this, what we get? After doing this, we get our signal as 0, and then 0 0.5, 1, 1.5, and 2. This is our scaling property. In this property, what we discuss is that we only divide our values by the scaling factor. After dividing our value with the scaling factor, what we get is our system. Here we see that by dividing this factor, we only change over the values of on x-axis, but our values on the y-axis will not be changed. That means there will be no effect of the scaling property on amplitude or otherwise on the y-axis scale. And next thing which we can see different example of this. This is the simple. And next thing which we are going to discuss is the inverse property. Inverse property. What is the inverse property? Inverse property is the property which inverse our system. For example, it repeats value about the zero axis. So for example, let's we have our system x of n, which is a unit vector, and we want to find its inverse. This will be x of minus n. This is our inverse. For example, we have a system as x of n 1. This is x of n. If we find the inverse means reciprocal, then what we will get x of minus n is equal to all these signals will shift towards the other axis, that is 1, 2, 3, 4, 5, and so on. This is our inverse property. In inverse property, what we do all inversing of our systems towards the x-axis. And then next thing which we are going to discuss is about compression. Compression factor or compression. What we do in the compression in compression system, we compress our values or decompress our values. In the compression system, we compress our values as, for example, if we multiply our system by the values, then it will be, if we multiply our system by the values, then it will be compressed. If we divide our system by the values, then it will decompress, it will expand. And if we divide our system by the values, then it will expand. Here, for example, we have the systems for different types of system. We define the different values of compression. And what is 2? 2 is here the compression factor. What is 2 in the below of x of 2, and this is our also 1/2 is our compression expansion factor. And next thing which we are going to discuss here is about the shifting property. What does we do in our shifting property? This is very simple. In shifting property, what we do, we do the values of our shifting. For example, if we have a system x of n plus 3, then we have to shift the system. For example, if we have the system x of n, it will shift as 1 2 3 4 3 4. This is our values, and we want to shift it by the plus 3 factor. If this is plus 3, then what means we will add the minus 3. Matlab, it will compress towards the left side. That is it will become -2, -1, 0, and +1. This will be our system. This is the compression factor. This is for today lectures. In next lecture we will be going further into detail of these systems and digital signal processing. Thank you very much.